Today we're going to look at multiplying algebraic terms. There's a few more things we need to learn before we move on from this topic. Let us first correct the homework from last night. Okay, so for the first one, you had 2x multiplied by 3y. So we know that we multiply 2 by 3 and x by y, and we get 6xy. For the next one, we multiply minus 3 by minus 9 to get plus 27, and y by c to get yc. For the next one, 4 by 6 gives us 24, and b by b, so remember with this one, b multiplied by b gives me b squared, and that was at the end of the last video. 8 by minus 4 gives me minus 32, and c by d gives me cd. Minus 9 by minus 2 gives me 18, and f by d gives me fd, or df if you want to put it in alphabetical order. 6 by 2 gives me 12, a by a gives me a squared, 5 by 5 gives me 25, b by b gives me b squared, minus b by minus 20 gives me 100 plus 100, and b by a gives me ba, or we can put in alphabetical order and say ab. Order does not matter with algebra. You will remember from our rule in the last video that a multiplied by a gives me a squared. I also gave you an example using numbers, so if we said 3 by 3, that's the same as 3 squared, which we know is 9. One of the things that we will look at later on is something called indices, and indices is exactly what we are looking at here with these two. An indice is something to the power of a number. So in this case here, we say 3 to the power of 2, or a to the power of 2. Later we will look at something called the laws of indices, and laws are basically just rules of indices. But let us look at the very first rule that will help us with algebra. So the very first rule in the law of indices is that a to the power of p multiplied by a to the power of q is the exact same as a p plus q. Now that might seem a little bit complicated, but let's just look at our example up here. So in our red example above, we had a multiplied by a gave me a squared. But if I look at my law here, what does that mean p and q is in this example here? What it means p and q is actually p here is 1 and q is 1. So that when I add both my powers together, I get 1 plus 1, which we know is equal to 2. This is the exact same for this situation here with 3 multiplied by 3. 3 has a power of 1, 3 has a power of 1. When I add them together, I get 3 to the power of 2. Why do we need to know this? Well, let's say for example, we have x to the power of 2 multiplied by x. Okay, so we know that that x has an imaginary 1 here. So that when we multiply both of these together, x multiplied by x is going to x to the power of 2 multiplied by x to the power of 1 is the same as x and adding the powers, which gives me x to the power of 3. Let us take another example like ones that we've seen before. So we have 2x squared multiplied by 3x to the power of 4. Okay, first of all, remember we multiply our numbers together, and then we'll multiply the x squared and the x to the power of 4. So 2 by 3 gives me 6. Now remember from our law, this is x 2 plus 4, which gives me 6x to the power of 6. Let us take another example. However, we have a little bit of a problem here because x is squared and y is squared, but x and y are not the same thing. What do we do in this situation? Well, all we do is as before, we multiply our numbers, our coefficients, so 4 by 2, and then we've x squared and y squared multiplied by one another. So for the first part, we know that 4 by 2 is 8. What about this part? Well, remember from the first part of the last video, we said that when you're multiplying two variables that are not the same, we just put them down as normal beside each other. So we have x squared and y squared. And that's our final answer. We can't simplify that anymore. Let's take one more example. So we have 4xy multiplied by 4xy. How do we start this off? Well, first of all, we multiply the 4's together. Then we have the x's, and we can put those beside one another. Finally, we have the y's. Okay, let's simplify it. 4 by 4 gives me 16. X by x, we know by now, is x squared. And y by y gives me y squared. Remember, in all of these, we have little imaginary ones there, and we actually just add the powers to get these.